Global Finance, Topic 18, Global Investing, Constructing Optimal Portfolios that Combine Risky and Risk-Free Assets. Copyright Lou Gaddis. So we're going to try to look at the long-term effects of switching from a domestic to a global portfolio, both in terms of return improvement and volatility improvement. We'll also learn to calculate the return and volatility improvements, calculate portfolio future values, present values, and annuities, and compute value at risk. This first problem is a review from last time. It says you have a global portfolio with a standard deviation of 15% and a return of 8%, and the risk-free rate is 3. What level of return could I earn if I combine the risk-free asset and the global portfolio? So in this case, we have return, standard deviation. This global portfolio has a standard deviation of 15% and a return of 8. So it would be a point on the line right here. The risk-free rate is 3%. So I can combine risk-free assets and the risky global portfolio, and I can achieve any point along this line. This line consists of combining risk-free assets and global portfolio. If I extend out in this line, that would be borrowing at the risk-free rate and leveraging the global portfolio. So the question asks, what if you want a portfolio standard deviation of 7%? Well, if you want 7% standard deviation, you could read a point on this line and get this level of return here. So this problem asks you to solve for that, and you're going to use your equation of a line for the capital allocation line, which is right here. Except you'll first have to calculate the Sharpe ratio. And remember, the Sharpe ratio is going to be the return of that global portfolio minus the risk-free rate over the standard deviation of the global portfolio. And the second problem says how much do I have to invest to get the risk-free asset. So in this problem, you're going to use our equation that when you combine a risky and a risk-free asset, the combined total standard deviation is the weight in the risky times the standard deviation of the risky. So this will be the standard deviation of our global portfolio. This is the standard deviation of our combined portfolio, and we'll solve that for the risky. However, this question asks for the weight in the risk-free asset, so make sure this equation gives you the weight in the risky asset, so you will need to subtract 1 to get the weight in the risk-free asset. So we're going to do a couple more problems. Let's go back to the data I collected from 2003 to 2010 and found that the Sharpe ratio of a domestic portfolio was 0.24, and then the Sharpe ratio of the global portfolio, which was 50% US, 40% IFA, and 10% EMA, had a Sharpe ratio of 0.38. So we're going to look if we want a desired standard deviation of 9% or desired 5% mean, how to achieve the global or the optimal portfolio. So let's look at the first example. What if we want a target volatility of 9%? So again, here is our global portfolio. I draw lines down here. You can see that there's my 7% and 17%, and there's my domestic portfolio with a standard deviation of 15 and a return of 4.3. So this portfolio now we're looking at, if we desire a 9% volatility, we can get to this point on the domestic capital allocation line or this point on the global capital allocation line. So the first problem asks you to solve for this value here. Again, you can refer to your Angel quiz to get the answer. Using the equation of the line, you should be able to use the Sharpe ratio of the domestic portfolio to tell you what level of return. The second problem asks you to use the equation of a line again, using the Sharpe ratio of the global portfolio to get this value. The return improvement would be the difference between these two. Lastly, if you have $100 to invest, how much do I allocate to G? So if you decide you want to be at this point right here, you're going to combine the risk-free asset and global portfolio. So you're going to use your equation that the standard deviation that combines a risky and a risk-free is going to be the weight in the risky times the standard deviation of the risky. Use that to calculate exactly how much you have to invest in G. Now suppose your annual retirement contribution is $15,000 per year starting in 1 year for 40 years. How much will you have to have in retirement if you invest in a domestic portfolio that had the expected return of 4.34%? So in this case, we're going to use your financial calculators. Our 40-year investment, a payment of $15,000 per year. You're starting off with no money, so make sure your present value is set equal to 0. And set your interest rate to the domestic interest rate of 4.34%. And we're looking for how much money you'll have at the end, so you want to then compute the future value. Second problem, you just have to replace the I for the global portfolio of 658 and then recompute the future value. And then I'll show you how much better you'll be by investing in the global portfolio. Once you get the value of that global portfolio, we're going to add another question to it. So say at retirement you buy an annuity that makes annual payments for 30 years and earns 3.5%. So now you've retired. You're going to now receive money, make withdrawal payments for 30 years, and that money's left in an account at 3.5%. What is the value of the annual retirement payments? So in this question, you're going to solve for payments. You're going to set the present value equal to your retirement balance, which is the solution from this case. Your interest rate is 3.5%, 30 years, and then make sure your future value is 0 because you want to make sure all the money is gone. So the question is really asking how much can I withdraw from this account for 30 years if I plan to live 30 years after retirement. Once you get the solution to that problem, we're going to do a couple more things with it, and that is calculate the real purchasing power value of that payment. So once you get the solution to the last problem, you're going to figure out the annuity payment. However, that payment's not going to be received for 41 years from today. So again, back to our original problem, you're saving for 40 years starting 1 year from now. So you're actually retiring in 41 years. You then, at retirement, live for 30 years and withdraw the money. So the question is, that first payment that's received in 41 years, what is its value, purchasing power in today's dollars? So all you really need to do is take the value from the payment from the last problem and discount it at the inflation rate for 41 years. And since that payment is fixed for 30 years after that, your last payment purchasing power you can calculate by discounting, again, the payment from this problem for 71 years. So the idea is when you're, say, 21 years old, you save for 41 years, you then withdraw for 30 years, so you receive your last payment at, say, age 91 or 92. What is the purchasing power of that last payment? So a different type of problem we haven't done yet is looking at volatility improvement. We've done return improvement, the idea that for a particular level of volatility, how much greater return can we get from switching to a low Sharpe ratio portfolio to a high Sharpe ratio portfolio. And we're making the assumption that a global portfolio will have a higher Sharpe ratio because you're combining more assets that are not perfectly correlated. So back to our example where the domestic portfolio has a 0.24 Sharpe ratio and the global portfolio has a 0.38 Sharpe ratio. We can use an equation of line to compute volatility improvement. So again, here are our two portfolios. Here's our domestic portfolio. Here's our global portfolio. If we combine global and risk-free rate, we get along this line. If we combine domestic portfolio and risk-free assets, we get along this line. So in this problem, we're looking at what if we desire a 5% return. If we want to use the domestic portfolio, we can get it at a point, say, right here as 18.75% volatility. Or in a global portfolio, we can be right here with 11.84% volatility. That difference is our return volatility, our volatility improvement. How to compute these two numbers, 1875 and 1184, is using an equation of a line, but instead of using y equals mx plus b, we're going to solve that equation for x and say x equals y minus b over m. Or the standard deviation is the return minus risk-free rate over the standard or the Sharpe ratio. So for our domestic portfolio, right here, our desired level of combined return is 5%. Our risk-free rate is 0.5% in this example, and our Sharpe ratio is 0.24. And you can see that the point on that line shows you that you'll have an 18.75 volatility in the domestic portfolio. On the global portfolio, we just need to divide by the Sharpe ratio of 0.38, and you can see you get 1184 standard deviation. The return improvement is the difference between these two, or 691 basis points. We can also construct the portfolio of that global solution right here. So if I want to be at this point right here, and I had $100 to spend, I can compute the exact amount that will be in G and risk-free using our equation that the standard deviation of a risky and risk-free portfolio, or our one that combines those two, will be the weight in the risky times the standard deviation of the risky. So my combined volatility is 1184 on this line. My weight in the risky is what I'm going to solve for. My standard deviation of the risky portfolio is 17.8. I solve for W, and that gives me 67% of my money will be invested in G, 33% in treasuries. So in this example, we're able to reduce our volatility from 18.75% to 1184% and keep an expected return of 5%. So let's see what that means in terms of value at risk. So value at risk is like cash flow at risk and earnings at risk. It tells you with some confidence interval what your exposure is, how much you could lose. Our formula we're going to use for an annual VAR is going to be our V times the mean minus Z standard deviations. The V is the value of our portfolio, say at retirement. The mean is the expected return of the portfolio. Z is our standard normal variable, which is going to be set equal to 128, 165, or 233 standard deviations. And the standard deviation will be the standard deviation of our portfolio. So for example, let's calculate a 1-year 95% VAR if you have $2 million invested in a portfolio at retirement. And if you're going to invest in the domestic portfolio, say at retirement, your last year, you have $2 million invested. That's your V. Your expected return is 5%, and the volatility is 18.75%. So your VAR is going to be $518,000. So there's a 5% chance you'll lose more than $518,000 in that last year. Or you can also say you're 95% confident that you will not lose that amount. If you invest in the global portfolio, that also has a 5% mean, but the volatility is only 1184. So you can see our risk is much lower, almost half the risk of the previous portfolio, the domestic portfolio. So you can see that switching from a domestic to a global portfolio by lowering your volatility greatly lowers your probability of losses, or the expected value of losses. So here's a problem you can do using volatility improvement, just like I did a couple slides ago. So we're going to still use our 24 and 38% Sharpe ratios, except this time we're going to look at a 2% desired return You're going to calculate what return you get domestically. That'll be right here using our equation of a line, solving for return or standard deviation. And then we'll solve for G, the volatility, if you desired a 2% return, using our equation of line. But in this case, you're going to wind up using the Sharpe ratio for the global portfolio. The volatility improvement will be the difference between the solutions to those two problems. Then, using your solution you get for G, figure out how much you'll have to invest in the global portfolio to get to this point right here. So hopefully we've seen that we understand now the long-term effects of investing in a high Sharpe ratio portfolio, which is hopefully associated with a global portfolio, and shown the return and volatility improvements. And you've computed return and volatility improvements, portfolio future values, present values, and annuities, and value at risk.